Welcome back, guys. It's your boy the Ace, back with a Flipper Zero video as deemed well by the community. So in today's video, we're going to be diving into the murky waters of the hacking world and uncovering a favorite weapon of many attackers, red teamers, and pen testers and such, the evil portal. And no, before you ask, it's not a dark, broody version of a web portal designed by hackers who have an affinity for Black Sabbath and heavy metal music. On the contrary, it gets much deeper than that. So buckle up, turn up your speakers, and let's go. So first thing, what is an evil portal? Well, as much as it sounds like the entrance of a Luciferian cave headed by Antoine Lavane, it's much more mundane than that. But don't underestimate its power. An evil portal, or captive portal, is essentially a fake captive portal. It's designed to mimic a login page of a public Wi-Fi network like those you find in coffee shops, airports, hotels, etc. Now, as many of you might imagine, you can picture yourself in a coffee shop, like Starbucks for example. You're low on mobile data and you want to use the local Wi-Fi. You see a SSID, free Wi-Fi, coffee Wi-Fi shop, etc. Basically, it's free. You see no harm in that and you want to just use it. You might ask yourself, why is it evil then? The evil portal term originates from the Wi-Fi Pineapple, which was a pen testing tool designed for Wi-Fi network auditing and security. Now, this was dubbed evil portal because it was creating malicious captive portals, hence the name. How does the evil portal work? Now let's unmask the evil behind this and how it actually works. So to do this, a hacker uses a technique known as a rogue AP, or rogue access point attack. Essentially, the attacker sets up their own Wi-Fi network. Often this is stronger in signal and similar in name to match others in the area to lure unopposing victims in. Once you connect to the rogue AP thinking you're on a legitimate network, you are then directed to this evil portal. Now this looks like a regular login page, or it's like a splash page or an acceptance page that you've come across many times in companies and businesses around the world. If it's something that you are familiar with and happy to enter your credentials into, voila. The attacker has now got your credentials and maybe even worse, monitoring your traffic. Flipper Zero Evil Portal. Now, the Evil Portal app for the Flipper Zero Wi-Fi dev board was recently released by big bro dude 6119 with a co-contributor CodyTolene. So big up to them too for releasing this. It's been long awaited for the Wi-Fi front to discover more applications and capabilities that it could do. The Flipper Zero Evil Portal is a captive portal Wi-Fi access point using Flipper Zero and the Wi-Fi dev board. So of course this is a project in progress. Like I mentioned, it's still quite very new, primarily written in C and C++ with a little bit of HTML for the front end. This project will turn the Wi-Fi dev board into an open access point, which I kind of saw mention of before, but there was no real application until now for it. When users try to connect to this access point, they'll be served with a fake login screen. User credentials are sent to the Flipper Zero on board and then saved to the SSD card. Now, there's a disclaimer that the programmer themselves is not a C developer, is using this project as a way to learn more about the ESP32, Flipper Zero and C programming. So again, for educational purposes only. So let's get started. So there is a pre-built FAT file on the official untested as well as the unleashed firmware. For this example, I'll be using RogueMaster, who's already released this FAT file for his custom firmware. So that's the firmware of choice for this video. Link in the description below. So as mentioned, the FAT file will already be within RogueMaster. So if you want to use it there, you can. I'm sure other custom firmwares will also have it eventually. So the FAT files already available under the apps and GPIO folder within the SD card. So you could put Evil Portal and app data in that folder. So here's the hierarchy of that structure. You should be able to see it as that within the app section. If you want to create your own index.html, keep the file in mind that there is a 4,000 character limit within the file. So you'll have to optimize it for that length. And there is a note that they plan to increase it later, but run into some issues with large files. So like I said, it's a project in the making. It's only going to get better. And that's what I love about the Flipper community. So installing, flashing the Wi-Fi dev board. If you followed my previous videos, you're already familiar with Arduino and the Marauder application. So my current Wi-Fi dev board already has Skeleton Man's repo on it with the easy flasher for Marauder. We'll take this and we'll get rid of that so we can install this version and load the code onto the Wi-Fi dev board. So what we want to do is erase the firmware option. So there's a free prerequisites, of course. So here we can have the pip install for the ESP tool. As you can see, the requirements have already been satisfied. Next we shall set up tool dependencies as well, as that has already been satisfied. And lastly, we shall erase and flash the Wi-Fi dev board with the following command here. Now, as you can see, the flashing process has commenced. It's flashing on serial port 7. This will take a second to flash, and then we can get straight into it. Right, now that's flashed, we can move on to actually installing the code onto the dev board. So now that's done, we can begin the installation phase. So first we want to download Arduino. If you haven't done that already, I'll leave a link in the description below, but you should have done that if you followed my previous and initial Wi-Fi dev board Marauder video. Next, what we want to do is download a zip copy of this async TCP file. So let's do that. So we go to code, download zip, and done. Next, we want to download and zip the ES async web server also. So we go into this file, go into code, download zip. Next, we want to locate this directory under your users. If you're on a Linux system, this will be slightly different. Considering this is for Windows use, it's under users, documents, Arduino, and libraries, and done. So go to releases section on the repo and download the INO file. So let's do that now. So if we go up a bit, we go to releases. Here we have this INO file, we download that. First thing we want to do is place that INO file within this directory. This is important right now. So save that file into this directory. Next, when you have that file within that directory, it will create a folder initially when you launch it. Now the folder is going to be named Evil Portal based on the INO file's name. Now, once you've done that, what I want you to do is copy and paste exactly the folders that you obtained from the async TCP and the ESP async web server into this same directory. Keep the names as this. So the names need to be this. This is very important, guys, because it will not flash if the names are different. I believe the names come as master originally in the zip file. You do not want that. So rename that folder ESP async web server, and this one called async TCP. And this should be the file structure within this Evil Portal folder. Now you've done that, we shall launch that file. Now we have that file loading up and loaded. We have this INO file. So the first thing I want you to do is obviously update Arduino to the latest modules and boards if you haven't done so already. So next on our list is section 6. We'll go into File and Preferences. File and Preferences. Now under here, we want to select this additional board URL. Now copy these two and paste them into this location. OK and OK. Section 6 is now done. Section 7, we'll go into Tools, then Board. Then you can go to Board Manager. If you haven't already, you will simply type ESP32. Now, this is the one you should install. As you can see, I've had it installed already, but it's the ESP32 by Expressive Systems. Once you have that on board, you will now go into selecting that from your boards. So Tools, again, Boards, and then here you will select this one. It's third from the top for me right now, this ESP32 S2 Dev module. And that's what it should look like, and one tick right there. So that's done. On the ESP32 Wi-Fi, hold the boot button. Now you want to connect your Wi-Fi dev board to your PC, as so. Next, you want to hold the boot button down on this board. Then you want to hit the boot button, and with your other finger, press the reset button. Then let go both at the same time. Great. Now what should happen, you can go to Tools, and let's do that one more time because the port option didn't happen. I'll leave this in the video because, like everything else, it usually don't happen first time. So we should hold the boot button again and the reset button on the dev board for 5 seconds. Let go of them. And there we have it. So we should now be able to see, if we go into Tools, a port option here. And now you can see this COM7 port is available to us. Right, now we're getting a bit closer, guys. If you see down here, we have this COM port 7 available to us. So that is section 11 done now. Now, for section 12, what we want to do, we want to upload all of this code that we have obtained into the Wi-Fi dev board, which now on COM7. So just a quick recap, we flashed it. We should have uploaded the ESP32 S2 board. Now we have our port available to us. We have this code loaded, and the file structure should be as I showed here. So within there, it should be looking like this with all the source files for the web server, and for the async TCP, same thing, all the source files within here. If you can see the code, now I had this problem several times, but if you see the code, it's looking for these two includes immediately. As you can see, that the name here needs to be exactly the name of those folders, because that's where it's looking for it. And as you can see here, it's looking for it here. This was a huge mistake and many errors I was getting. It was really pissing me off. But it's finding it here, and it needs to be this exact name. So if you're hovering over it and you're not seeing that address line, something's wrong, because it's not finding it in that file path. So our next phase is to upload this on stage 12. So upload. And now you can see here it's compiling a sketch. Now, that took around 5 minutes for the initial sketch to upload. Do not worry about that error at the end where it says failed uploading with exit status 1. That's normal. What we do want to see and verify is this hash data verified. That means it's successfully flashed onto the dev board. So congratulations if you've got this far. So next we plug in the Wi-Fi dev board on top of our Flipper Zero. Now you can remove your USB cable at this point. Next, what I want you to do is press the reset button on the Wi-Fi dev board until you see a solid blue light appear. Now, if we head over to the Flipper Zero, as you can see, I'm currently using RogueMaster, and we hit the down and back arrow, we can go into GPIO. From there, we can see the newly added FAT file in the latest firmware release, link in the description below, called Evil Portal. Now, if we've done everything right in our previous steps, from here, we should be able to click Evil Portal and run the application. Now, from here, you have a few options available to you. You have Started Portal, Stop a Portal, Save the logs of a portal, or Help. So when we start a portal, now we can see it's starting a portal. Now, the Flipper itself should be turning a few different colors. In my instance, it's turning green. And on the screen is exactly the text that you see right here. Now, as you can see, it starts the portal. You have the option to hit the back icon. It's set a HTML and it's set an app. So it's saying that the app is set. And now you can see here, it started a Rogue AP with the SSID Google Free Wi-Fi on a default IP address 192.168.4.1. Started this web server up. Now, the moment of truth is whether if that SSID or access point is available to us in our Wi-Fi. And bam, there it is, guys. There is the proof of concept right there. It's available. And can we click into it? And if we do, what happens? So it's an open network. And there you have it, guys. So once we actually connected into it, we can see that the access point itself has no internet or pass-through capabilities just yet. And that might be able to be leveraged later on as the application develops. But what's important, it has spun up a locally hosted, on the Flipper Zero, a Rogue access point and web page. Now, if we enter some test data in here, test@test.com, and 1, 2, 3, 4, 5, 6, and we hit next. Now that data has essentially been absorbed by the Flipper Zero. If we check our logs, what's actually happened. And there you have it. Now, as you can see, we spun up the Rogue access point on the 192.168.4 IP range, and the web server was active. And once we entered those dummy credentials, we essentially swiped them immediately. We could see the connection from the client was established. We can see an established connection from the client was initiated. We can see the username as test@test.com, which I just entered, and we can see the password of the dummy password, which I entered. Game over. Now, if we just go back into our normal access point for now, and we want to explore just a little bit more of how and where the log files are actually saved. So in terms of the usage, as we saw, we can start the portal, which we did. The AP will take the name of whatever's in the AP config text file, and that's located under app data and evil portal folder. So let's try and navigate to that and see what that actually looks like. But amazing work, guys. Absolutely amazing. I really like it for even at a beta stage. Really good. So we can save the logs. That's saved. We can stop hosting that portal. That's stopped. It's under app data, not apps. So let's go back again. Under app data, we can see evil portal. And there we have it, guys. Here's the codecs here that we need to change and edit. Now, I'm going to completely rip this apart and produce something quite nice later on. This is just a proof of concept on essentially what is an early release. Here is the log files of the dummy credentials we harvested. Easy. So, how do you fight off the evil in this scenario? So for me, you need to validate a network. So always check with your staff or with personnel in your home to make sure they get the correct name of the network and have a legitimate process of how you log into that network. If the network doesn't require a password, I would be very suspicious, even if it is a known network. Anything free comes with a price. Use a VPN. For me, I use several, but I would use a VPN or virtual private network that encrypts your data. This at least prevents it from being read or intercepted, which brings me on to HTTPS only. If you're connected to a private Wi-Fi network, try to only visit sites that have HTTPS encryption. This will mean that your data is scrambled over the net. Next, turn off automatic Wi-Fi connectivity. Your devices might automatically connect to networks if you think it's recognized or you know them, which is basically like inviting a hacker in to your house for a nice cup of tea. Lastly, keep your software up to date. Regularly update your software and patches. Now you're equipped with the knowledge to fend off these evils. Like Jay says, stay clear of the evils. And like the Ace says, stay safe in the cyberspace. So make sure you subscribe and peace out.